Welcome to the Graph Theory playlist. Hello. In this playlist, we are obviously gonna talk about blueberries. Of course not, right? We're gonna talk about graph theory and graph algorithms. Now, these graphs are not those curves and plots, but something different. I often like to call them as networks, as I find it as a better name for them, and I think you will also find the networks as a better name for these things. But maybe mathematicians use that word for something else. Now, we are here to discuss why are graphs studied, but let's first discuss what are graphs. So, graphs are essentially a collection of points. And these points on a 2D plane, they are connected with lines. You know, I mean, not all points are connected with some other point, but different points are connected with different points, you may say it as. And this is a diagrammatical representation. But this diagram may represent anything such as a social network, routes between towns, some complicated molecular structure, a network of computers, biological networks like metabolic networks, Google's knowledge graph, which is an interesting thing of its own, and I suggest you must search for it, or even Euler's Königsberg bridge problem. Now, what is this? See, we may declare Euler's Königsberg bridge problem as the beginning of the study and analysis of graphs and its methods. But let's first have a look at this thing, and this is interesting. So let's first have a look at this. And so I made a funny diagram which basically is, so these yellow things are four islands, and these orange things are bridges between these islands, connecting these islands, and this dark black thing is the sea. The sea is, I mean, just representing. And so I'll first read you the problem. So first of all, some backstory. So in the city of Königsberg in the Prussian Empire, now it's in modern day Russia, and this is mid 18th century. So the mayor of the city proposed an interesting problem which states that can you find a path walking on which will lead you to cross every bridge only once. So basically walking on which will lead you to walk on every bridge for once at least, but only once. So basically you have to walk on every bridge, but at most once. I may have spoke something wrong in before this, I apologize. So so final time, final take. The final take is, so the question is that you have to walk on every bridge, but you cannot walk on any bridge twice. You can walk on it only for once. Now, pause the video here and think of the solution. What can be the solution of this thing? Okay, pause the video here. Come on. Come on, are you pausing it? Okay, now I'm going to tell you the answer. Okay, you didn't pause. Euler found out a solution for this, and he basically said, nope, you can't. And he also gave a reason. And the reason is quite simple. If you think it logically, you will see that if these blue points represent islands and these green lines represent the bridges connecting them, so there are only two kind of solutions for such a kind of problem. Say you can walk on any bridge only for once. So for entering an island you need one bridge, and for exiting it you need another bridge. So you need bridges in pairs, except for the endpoints, because you have a starting point and you have an ending point. So starting point just needs an exit bridge, and ending point just needs an entering bridge. So either you have one bridge for starting and ending points, and even number of bridges for all other points, or you have even number of bridges for all of them. And this would be the solution. But when you look at this particular case, the case of Königsberg bridges, you will see that these islands, let's name them as LMAO, and see this diagrammatic representation. So L is connected with three bridges, M is connected with five bridges, A is connected with three bridges, and O is connected with three bridges. So that means the solution is impossible, because we just now saw what should be the real scenario if we want such a kind of solution. But this interesting problem led to the beginning of an entire new branch, the entire new branch of graph theory. Euler called it geometry of position, and our academic syllabus got bigger. But actually, I like graph theory, and I like graph theory and algorithms, and I'm sure that you will also like them because they are so much fun. So I must say that this led to the beginning of an entire new branch of graph theory, which has numerous applications in the modern world. So we'll meet in the next video and discuss about the representation of graphs. Until then, bye bye and see you.